Friday, we talked about a couple different triangles. We talked about isosceles triangles with our base angles theorems and stuff. We talked about equilateral triangles a little bit. Today, we're going to round it out by talking about right triangles. We get one special extra proof reason with right triangles that's going to help us out here. Some quick vocab about right triangles. If you don't know, the longest side of a right triangle is called the hypotenuse. We know it's the hypotenuse because it will always be directly across from the right angle, right? That's kind of the definition of a hypotenuse. And then the other sides of a right triangle, we call those legs. Same vocab word we used with those isosceles triangles. The other sides are called legs. We have the hypotenuse, we have the legs. The definition of a right triangle is just any triangle that has one right angle in it. So you might see this as the definition of a right triangle. Just has a right angle in it. That's all. So, if you remember back to like the first quiz that we did in this unit, we learned 4 ways to prove triangles are congruent. SSS, SAS, ASA, AAS. We are now going to learn a 5th reason that we can prove triangles are congruent, and it is specific to right triangles only, and that is called HL. If you can guess what the H and the L stand for, it stands for hypotenuse leg. So there are 3 parts that we need to be true in order to prove triangles are congruent using this reason. We need 2 pairs of congruent hypotenuses. So we has to be the hypotenuse that is across from the right angle in that right triangle. We need 1 set of congruent legs. And then the third and final thing is the thing that's going to get tricky, is that we have to prove that these 2 triangles are right triangles. We're going to do that using the definition of a right triangle, which literally just needs a right angle. But that's the part that we're going to forget the most often, is to prove that my triangles are right triangles first before we can use hypotenuse leg. Questions on that so far? Our proofs are basically going to follow the same pattern that they always do. I'm just giving you an extra reason that could be used in place of SSS, SAS, all that good stuff. Okay, so we're going to hammer this home. We're going to assume C is the midpoint of BD, which tells me that these 2 sides must be congruent. I'm going to assume C is the midpoint of AE, which means these 2 sides are congruent. Now that third thing, in order to use HL, that I need to know is I need to prove these 2 triangles are right triangles. So I would have to say triangle ABC and triangle, how would I do this? EDC are right triangles. So if I wanted to use HL, that is what I would need. I would have to do a step before that to say that my 2 angles that are across from my hypotenuse, which let's call those angles B and D, I would have to say that those are right angles in order to say that I have right triangles, but I cannot just use the fact that angle B and angle D are right angles. That by itself is not enough. Does that make sense what I'm saying to you? Okay. By itself, right angles are not enough. We have to go on and say that those are right triangles. Okay. Let's do one where we're solving. This is a system of equations we're going to get here. If you're not super comfortable with systems, please, please, please practice your substitution or elimination. It was on your quiz. It will be on your test. It's not going away. For number 2, it says, what values of x and y are the triangles congruent by HL? So I have to make sure that I'm lining up the hypotenuse together with the other hypotenuse, which means I'm going to line up the 6y and the 4x plus 2. And I'm also going to line up the legs together, x plus 4 and 2x minus y. Okay, both equations have an x and a y in them, so I'm going to pick whatever method is easiest for me. I prefer to use substitution. If you're an elimination kind of person, that's all power to you, man. Do your elimination. I'm going to substitute this. I'm going to get that y in that second equation by itself. So let's subtract 2x. Let's get negative x plus 4 equals negative y, and divide by a negative 1. So there's my y all by itself. That's what I like to see for my substitution. I'm going to substitute this into my other equation. Oh, sorry, not for x, for y. Right there. So this should look like 4x plus 2 equals 6, and I'm replacing y with x minus 4. And solving. So x is 13. Everybody got that far? To finish off my substitution, I take that x, I'm going to plug it back in to find y. 13 minus 4 equals y, or 9 equals y. Any questions on that? Again, substitution and elimination not going away. If you need some extra practice on that, let me know. Are we good on that stuff? Let's move into the proofs. We're going to do it. It's going to be all right. It's our last bit of proofs, and then never again. Okay. Our proofs start the same way. We're going to go ahead and put our proof statement at the end, like always. Take that proof, put it in the last step. Triangle BEA congruent to triangle BDC. My first given is that EB is congruent to DB. That's here and here. Hopefully, you're marking up your diagram as you go. I hope you are. I know some of you, I've seen it on your quizzes. That's fantastic. We're marking things. Hopefully, when you mark this, you see that EB and DB are the hypotenuses of these right triangles. So my brain is already thinking about hypotenuse leg because I have a hypotenuse that is congruent to another hypotenuse. So my brain's working already. I move to my next given. A and C are right angles. Now, normally with this given, if I was trying to use something like angle side angle, I would go on to the next step and say A is congruent to C by all right angles are congruent. But that's not what I want for hypotenuse leg. Hypotenuse leg does not use any angles are congruent to each other whatsoever. So maybe make yourself a note here in step 3 that I don't want to say angle A is congruent to angle C by all right angles are congruent. That's a good reason, but it's not going to help us use hypotenuse leg here. Instead, when I know that angle A and angle C are right angles, what do I want to then say? Any ideas? Think about what 3 things hypotenuse leg needs. I've got my congruent hypotenuses. I know I'm going to need to find a leg. That third thing that I need is that these 2 triangles are right triangles. So instead of saying by all right angles are congruent, A and C are congruent, I'm going to say triangle BEA and triangle BDC are, I'm going to run out of room, are right triangles. Can you see that, hopefully? And our reason for this is, as long as I have right angles in my triangles somewhere in my proof already, I can say that they are right triangles by the definition of right triangles. That's going to be a new proof reason for us, is that definition of right triangles. I'm going to highlight it, maybe. I did not like that highlight. Questions on that? So now, the 2 things that I have hypotenuses are congruent, I got right triangles are congruent. I have right triangles. Now I need a set of legs that are congruent. I look into my givens. I still have one given left. B is the midpoint of AC. If B is the midpoint of AC, I'm going to get my my set of legs here. I'm going to say that AB is congruent to CB. My reason, that's the definition of a midpoint. And now I have my three parts. I have the hypotenuses are congruent, I have a set of legs are congruent, and I've said that those triangles are right triangles by the definition of right triangles, so I can go ahead and use HL. I'm proving two triangles are congruent. It's just like SAS, SSS, all those things, except it's called HL. Good? Any questions on that? Okay, let's do another one. These things get long because I've got a lot of steps to prove things are right triangles. So, in letter B, again, I'm going to take my proof statement, I'm going to put it at the end. Nothing new here. I'm going to take my first given. MO is congruent to NO. I'm going to put that first. That's here and here. So looking at this right now, maybe you can tell MO and NO, not the hypotenuse, right? The hypotenuse should be the longest side. So right now I'm thinking I probably have a leg, or maybe I don't have hypotenuse leg at all. I go to my next reason. It says OM perpendicular to LM. What does that tell me in this diagram? OM is perpendicular to LM. Presley. Angle M is a right angle. What's my reason? Definition of? Caitlin. Definition of perpendicular lines. I'm going to repeat that process with my next given. So ON and LN. Oh, let me mark that. I can mark that. So if I know ON is perpendicular to LN, that means that angle N is a right angle. Remember, this is a pattern that we see a lot. And now what am I going to say in step 6? I did all this work. I got M as a right angle, N as a right angle. What's step 6 going to be? Any ideas? Dahlia?
Reflexive property congruence.
For which one?
LO is congruent to LO.
Okay, I'm going to put that at the end because we do need that. But that's separate from this part. Anna? Do we want angle M is congruent to angle N? That would tell me I have an extra angle to work with. Allegra? Perfect. We're trying to use hypotenuse leg here. So I'm going to use that triangle LMO and triangle LNO are right triangles by the definition of right triangles. So now I have that they're right triangles, I have a leg, and then Dahlia gave me that the hypotenuses are congruent by the reflexive property, right? That was step 7. So now in step 8, I should be able to use hypotenuse leg. Does that make sense? Let's talk about why we shouldn't say that M and N are congruent. Imagine I did say M and N are congruent and not that they're right triangles. What would my reason be if not HL? Dahlia. It would be SSA or AAS, right? We know that that's a no-no. So if I get there and I'm like, wait a minute, I have these two sides. I said that these two angles are congruent, but now I'm looking at SSA. That can't be a reason. So that's telling me in my head, hey, I have to use HL here. I have to use that those two right angles make the triangles into right triangles, and then use HL. Does that make sense? Okay. All right, last one. This one kind of got a little bit messed up, so let me help you out. This first given says JP is congruent to MW, and the proof statement says JM is congruent to WP. So let's put our given in, JM congruent to WP. Let's put our first given, JP is congruent to MW. Okay. Where am I looking here? JP congruent to MW. That's this and this. Take a look at that proof statement. I took my proof, I put it at the end, right? JM and WP are here and here. I'm putting it in purple because we haven't actually proved this yet, so we can't use it. But look at JM and WP. That kind of looks like it's going to be the hypotenuse of this triangle to me, right? So as I'm putting in my proof statement, maybe I'm starting to think, wait a minute, I'm not going to be able to use hypotenuse leg here because I already know that my hypotenuses aren't going to be congruent until the last step. So maybe that's something to think about. Maybe you don't think about it. That's okay. I have my first given. Let's look at the second given. Angle 1 and angle 2 are right angles. So if I know that angle 1 and angle 2 are right angles, what am I going to say in step 3? What do we want to put in step 3? I'll take your wrong answer even if it's wrong. Or you can give me the right answer. Presley? Okay, let's go with that. Let's say triangle JPM and triangle WMP are right triangles by the definition of right triangles. Step 4 would be what? What would my step 4 be? I'm missing a third piece. I need like a reflexive or a vertical angles or something like that. What am I missing? What am I missing in this diagram? Oh boy. How about this? How about PM and MP are congruent? Can I use that? That's my reflexive. Now, I have in my proof statement that a segment is congruent to another segment. So I know that somewhere I need to say that my triangles are congruent. So let's put that in step 5. Triangle JPM is congruent to triangle WMP. And now, what are we going to say for this? Think about the parts that I have. In steps 2 and 3, I proved that this was right triangles. In step 1, is this a hypotenuse or a leg? Right here in red. What do you think? It's a leg. And then what about in step 4? Did I get a hypotenuse or a leg here? Also a leg. Can I use hypotenuse leg with 2 legs in a right triangle? No, I can't. So, if I run into this problem, what are we going to do? Well, I'm going to go back to where I said that those triangles were right triangles, and I'm going to fix this step. Instead of saying that they're right triangles, and instead of saying that those are legs, let's just call those sides. And then what would I do in step 3 instead? Instead of saying that those are right triangles, I'm going to reverse time travel back to before we knew about HL. How would I solve this? What do I need? Caitlin? Yeah, I'm going to use SAS. Instead of saying angles 1 and 2 are right angles, therefore I have right triangles, I'm going to say angles 1 and 2 are congruent, by all right angles are congruent so that I can use SAS. Do we see what's happening here? At the end, we're getting stuck, right? Before, I got stuck because I had SSA. That doesn't work. And this one, I got stuck because I don't have a hypotenuse. So I had to back it up, go back to SAS. That's okay. It happens. Step 6. What's my reason for step 6? Finish it off, Dahlia. Perfect. Again, remember how I said JM and WP, that's going to come back to haunt us? JM and WP, those were the hypotenuses. If you notice that, the hypotenuses is what we're proving. I can't use hypotenuse leg, right? Okay. All right, that's all I got.